On page 636, you have the following four formulas, and these formulas are on your formula sheet as well, and they look extremely scary. Okay? Because there's lots of sines and coses. We've got two Greek letters. Usually, what letter do we use for angles?
Theta.
Theta. That's like the most common Greek letter for angles. Except once you get more than one angle in a question, then they start using alphas and betas. First angle's alpha, second angle's beta. And we're going to deal with a lot of questions that involve these formulas. First of all, you can never do this. This is not allowed. You're going to be tempted to want to do this. You're going to want to distribute, but we can only distribute numbers or variables because variables represent numbers. Sine is a function. Just like you can't distribute a square root. Right? Just like this is the number one mistake on a grade 9 exam. Students write this. What did they forget to do? You can't just put the square to both ones, right? You have to do a plus b times a plus b. So all of this is tempting, but we can only distribute a number or a variable. We can't distribute a function. So then the question is, well, what happens when I have sine alpha plus beta if I have two angles added together? It actually becomes this very, very big formula. And these are on your formula sheets. And you don't have to have them fully memorized, but I feel like you need to have them mostly memorized. And by mostly memorized is if you see the right side with a whole bunch of sines and coses, you should say, I should look at my formula sheet. It's probably one of those. Because they're all very similar, right? So it might be hard if you're like, oh, sine cos plus cosine. Which one is that? Well, that's where you have it mostly memorized. You just know that you should look at your formula sheet to see if you can match one up. Okay, so what we're going to do is we are going to work with these formulas, and we're going to find out by having these formulas, I don't know if it was bothering any of you on your pie plate, that the spaces weren't equal. Because between 30 and 45 is 15 degrees, but between 0 and 30 is 30 degrees. We're going to be able to add to our unit circles all the 15 degrees ones that are missing using these formulas. You don't have to actually add them to your plate, but we're going to figure them out. We're going to do things a little bit different. We're going to start with question number 2, which is not question number 3. Here we go. Oh, and also you have on page 638 the formulas for tan. So you got 6 new formulas. Sine alpha minus beta, sine alpha plus beta. Cos alpha minus beta, cos alpha plus beta. Tan alpha minus beta, and tan alpha plus beta. And they are all on your formula sheet. So sometimes you're going to be asked a question like this. Write each expression in simplest form. And in all of those formulas, we always consider the left-hand side the simplest form. The right-hand side the expanded form. And it says evaluate where possible. Well, in A, we've got sine cos minus cos sine. And we've got an angle of 8x, so I'm going to call that my alpha and my alpha. And 3x, I'm going to say that's my beta and my beta. And then I'm going to look on my formula sheet, is there a sine alpha cos beta minus cos alpha sine beta formula? And it's that very first one. So on my formula sheet, it is sine alpha minus beta. So that means in part A, I can take this whole thing and use the identity and switch it to sine 8x minus 3x, because this was my alpha, this was my beta. And of course that simplifies to sine of 5x, and we're done. We've simplified it. So changing it from the left side to the right side to left side is something that's going to happen a lot with these identities. The simplified version is the left-hand side, because this looks a lot simpler than it was originally. Part B, I'm going to choose, so I'm going to look at this and say, okay, this is my alpha, this is my beta, this is alpha, this is beta. Is there a formula on my formula sheet that has tan alpha plus tan beta over 1 minus tan alpha tan beta? So I look at my formula sheet, see if any of them match. Sure enough, this is equal to my tan alpha plus beta formula. So I can go and take this question and rewrite it as tan, my alpha was pi over 6, my beta was pi over 12. How do we add fractions? We get a common denominator. So this will be 2 pi over 12 plus pi over 12. That'll come out to 3 pi over 12. And if you reduce that, it is, not only is it reducible, it's on your pie plate. What is tan of pi over 4? 1. That is a lot simpler than what you started with. Tan of pi over 6 plus tan of pi over 12 divided by 1 minus tan of pi over 6 tan of pi over 12 will equal 1. You type it into your calculator, but the simplification made us able to do that without a calculator. All right, circle questions 4 and 5.